All right, we'll take a look at problem solving strategies and word problems. So we'll develop and apply general strategies for solving word problems. I always like to use, kind of say this as a joke, but at the same time, it's a pretty good way to go about solving word problems. Is I guess when I do word problems, I write down my givens. What givens do I have? What are the unknowns? Like what are we solving for? And we'll assign a variable for them. What are the equations that are given or implied sometimes, like if you're just talking about area, you should know area is length times width of a rectangle or whatever, right? And then you'll usually substitute and then solve. So we're guessing. That's kind of our approach here. So here's a first one example here. States High School Athletic Association separates its schools into two divisions. Division 1 and Division 2 they have a total of 332 schools. Let's let and then it says there are about 5.5 times as many schools in D1 than D2. How many schools are in each division? So those are our variables. Let's let X be the number of schools in Division 1. Y will be the number of schools in Division 2. And then what are the givens here? Well, there's a total of 332 schools. So we know X plus Y equals 332, right? And then we also know there are about 5.5 times as many schools in Division 1 than Division 2. So there's less Division 2 schools, right? There's less Division 2 schools. So you're going to go 5.5 times as many in Division 1. So 5.5 times the lesser amount is how many there are in the higher amount, which is Division 1. All right, so there's what we know, and those are our equations as well. So now we're going to substitute and solve. So what I'm going to do is I'm going to take this first one, X plus Y equals 332. I'm going to solve for one of the variables. Let's go ahead and solve for Y. So I'm going to subtract X on both sides. So Y is 332 minus X. And so here's what Y is. I'm going to plug it in right there for Y. So I'm going to substitute into the other equation. And now I'm going to distribute that. So I got, let's see, 332 times 5.5. I get 1826 minus 5.5x equals x. Let me get all my x's on one side. Let me go ahead and take them to the right here. Add 5.5x. So what we have is 1826 equals 6.5x. And now we're going to divide by 6.5 and solve for x. And so it looks like we got, oops, come on, no, don't want that. 280.9230769 equals x. So we'll just round that to the nearest whole number. So 281 is the number of schools, Division 1, right? 281. Well, since we know, lastly, since we know x is 281, and we know x plus y is 332, and we know 281 plus y equals 332, I subtract 281 from both sides, and I end up with 51. So 51 in D2. So 281 schools in D1, 51 in D2. That's just the answer on that one. You know what? I forgot to update it. This is not the one I want to do. I will do a different one. Let me come back to this. We're not working on that in this section. Let me do a mixture problem and then a geometric problem, and then I'll do a what I'm going to call a concert problem after. That'll be the one I should have had in there. I need to update this. Sorry about that. Pharmacist wishes to mix a solution that is 2% minoxidil. She has on hand 100 milliliters of a 1% solution and wishes to add some 4% solution to obtain the desired. Okay. So what we're going to do is we're going to let, how much of the 4%? Let's let X be the number of how many milliliters of the 4% solution that we need. So right now she has on hand, so let's make what she has. She has 1% of 100 milliliters. Let me do that with an L like that. And then we're trying to figure out, we're going to add in a more potent 4%, 0.04, 4% of X. This is how much number of the milliliters that we're going to put in of the 4%. And that's going to make us the 2%. So how much do we end up with of the 2%? Well, we already have the 100 milliliters, plus we're adding in X amount of the strong 4%, right? Because we're trying to end up with a 2% solution. So this is total, right here's our total milliliters. Between total milliliters, we already had the 100 and we're adding in X more amount. Does that make sense? All right, let's see what we get. So 0.01 times 100 we got 1 plus 0.04x equals, and we got 0.02 times 100, which is 2 plus 0.02x. Let's get all our x's on one side. So 0.04 minus 0.02, and we get 0.02. And we subtract 1, we got 0.02x equals 1. And then 1 divided by 0.02 is 50. So we need 50 milliliters of the 4%. Of that stronger 4% in order to have a 2% solution at the end, right? All right, a rectangular plate is to be the base of its circuit board. Get this rectangular plate, and its length is 2 more than its width. So the length is 2 more than the width, and has a perimeter of 36 inches. Perimeter is 36 inches. Find the dimensions. Well, we know perimeter is length plus width, right? We add up all the sides. And we know the perimeter is 36 already. And finally, we know the length is W plus 2. So that's going to go in right there. Perimeter is 36. Our length is 2 more than the width. And that's how we'll find our width. We've narrowed it down to one variable. So now we can solve for W, and we'll have our width. And we can then solve for the length after that. 2W is 2W. We got 4W plus 4. Let me subtract 4 both sides. So that 32 equals 4W. Let me come up here. 4W equals 32. So it looks like our width is 8 inches. So now we know the width is 8 inches, and we know the length is 2 more than the width. So the length would be 8 plus 2, so our length would be 10 inches. All right, so this is the dimensions would be length times width, 10 inches by 8 inches for this rectangular plate. Okay. All right, so here's our next example. If 105 people attended a concert and adult tickets were $250, children tickets $175, total sales was $228 for all the tickets together. So how many were adults and how many were children that attended? So let's look at, first of all, how many people attended, and I'm going to write that first. My adults, so let me let A be the number of adults that attended. Capital C will be the number of children that attended. And we know, or what our givens are, is there's 105 people that attended in total. So adults plus children, there's 105. Now, in addition, we don't know how many at this point adults and how many children, but we do know sales. So 250 times the number of adults, that's how much money we bring in from the adult tickets. $175 per child. So that's how much money we bring in for the children tickets, because the total sales were $228. Total sales. So what we're going to do is we're going to do substitution again. I'm going to go ahead and solve for, let's solve for the children on this first one. So let me subtract A on both sides. So children is 105 minus the A. So I can plug this in for C right there. And we can solve that. 2.50A plus 1.75 times the children, which is 105 minus A. And now we just got to solve this. So I got 2.5A plus 105 times 1.75, 183. 75 minus 1.75A equals 228. I'm going to combine like terms. 2.5 minus 1.75 gives me 0.75A. Remember, we're solving for A. Now we're going to divide by 0.75. Gives me 59. So there's 59 adults that attend. So now I'm like, oh, I know there's 59 adults that attended, and the total number of concert goers is 105. So let's plug in the 59 for A. And the number of children would be 46. So 46 children went, and 59 adults went. And I hope that's enough to get you started. Thanks for watching. See you next time.